Hi, everybody. Mr. Rubo here. Today we're going to do topic 2.3, exponential functions. These three are our big functions that you see in Algebra 1 all the way through calculus and beyond, really. But they also show up on the SAT and ACT. These are big functions. We deal a lot with them. And yeah, we've talked linear, we've talked quadratic. Now we're getting into more exponential stuff. And so that's what we're going to focus on here. So exponential functions are some of the most important functions in real world applications. So you see this population growth, you see this money with interest and debt, you see it in chemistry, you see it spread a disease, unfortunately. But SAT, ACTs, you'll see these all over the place in those as well. So a few things. General format is f of x equals a times b to the x. A represents the initial. So what we start at 0 time. And then b is what we call the common base. Or what we saw it in the sequences, the ratio. So ratio and base will be interchanged either way. Okay. So there's kind of two types of exponential functions that we deal with a lot. Tyler, there's other ones, but when our a value is positive, so the leading term is positive, if the b value, if our base is greater than 1, we have exponential growth, meaning as you increase your x's, the y values increase. Exponential decay, on the other hand, still our a value is positive, but our b value is between 0 and 1. So it's going to be some fraction or decimal that's less than 1, and this will give us a decay. It'll get us where we are decreasing the entire time, which kind of leads us into this next thing, increases versus decreasing. Exponential functions are always increasing or always decreasing. You do not have a switch. Okay. They will never switch from one to the other, so they have no relative. Oh no, my there we go. Oh no. Sorry, my pen. There we go. No relative or local. Okay. And as far as concavity goes, exponential functions are always concave up or always concave down. They will never switch concavity, so they have no points of inflection. It says no points. Okay. As far as their end behavior goes, there, my one thing messed up there. For the end behavior, you are either increasing or decreasing without bound. For the x values, just like always, because that's how we say end behavior, the y values will either increase or decrease without bound, or they will approach 0 for this general format. Okay, so you're either going to have they go to infinity, negative infinity, or they're going to go to a specific 0. So, and we'll kind of see examples here. Yeah, my first graph definitely didn't notice that when I was starting, but I'll kind of redraw it here. It looked like that. Okay, so let's go ahead and do this first one, which mine unfortunately is not there. Like I said, I just drew it. So left-hand limit, well, that means right away, no, I'm going to say as x approaches negative infinity of the function. I don't know what this function is, so I'm actually just going to put a b to the x equals, and on the left side, it's not going towards infinity, it's not going towards negative infinity, it's actually coming to 0. So in this case, the left hand is 0, right? We're looking right here. And then the right side, hey, the right side, that guy is going to positive infinity. So I'm going to write the function here, but this time the right side is going to positive infinity. So yeah, we'll do the next two in class, but yeah, there you go. Have a good day.